So now that we've looked at things in a straight line motion, let's go ahead and take this back to the argument of centripetal inward force versus centrifugal, the outward force. So let's go ahead and draw a nice sharp curve, a nice large sharp curve. And let's put a nice big car about to make it through the turn. And for argument's sake, let's do some special things with this car. Let's first of all, let's not put any door on the passenger side, on the driver's side. Let's go ahead and put a person in there. So the easiest way to draw a person is to make a circle, draw little portions here to represent the shoulders. Because a person has legs and feet. Person sitting in the car. Let's put a person in the back seat also. Backseat passenger, front seat passenger. Let's call this guy in the back observer number 1. Let's also put a person back here on the edge of the road. For some reason this person has a very large head and their feet. So this person's standing on the road. So let's do a couple of things. Let's assume, let's go ahead and put this in view, sorry. So down here we're going to call this guy observer number 2. So we're going to send this car around the curve. Now let's set up some special conditions for this situation. Let's first of all, let's assume that there's no friction between the seat and the passenger. Now, the car, what's going to ultimately happen is the car is going to travel around the curve, and as the car travels around the curve, the person in the seat is going to end up going out the door on the right side. And this is something that you might imagine happening. If you went around at a high rate of speed, the person might go outside the door to the right. So let's look at what Observer 1 says happened in that situation. Observer 1 says the following: I saw the person out of the right side of the car. So, therefore, there must have been a force to the right. Observer 2 says this. Remember, observer 2 is down here in the right. When the car turned, So what really happened in this situation? Observer 1 says, I saw the person in the front seat fly out of the right side of the car, so therefore there must have been a force to the right. The second observer says, when the car went around, the person moved in the same direction while the car moved to the left. The person moved in the same direction at the same speed. What happened was not that the person flew out of the car, but rather that the car flew out from under the person as they continue to travel in the same direction. This is because observer 1 is accelerated while observer 2 is inertial. Observer 2 makes the correct observations. So besides looking at the situations we've looked at so far, we'll also look at roller coasters with loops where you seem to stick to the seat even when you're upside down. We'll examine the forces more closely. Another ride at the amusement park that's very interesting is the silly silo, where you seem to stick to the wall and the floor drops out. And centripetal acceleration helps us to understand that. And lastly, we'll look at satellites orbiting around the Earth or the Earth around the Sun and use centripetal acceleration to understand why objects orbit others.